Lesson 6-2. Apply properties of rational exponents. Alright, properties of exponents are the same as we've had before, so we're not going to go too far in depth with them. I'm just going to point them out again. If you multiply with the same base, add the exponents. If you have two different bases multiplied together, so x times y to the m, you distribute an exponent through multiplication. If you have exponent parenthesis exponent, multiply the exponents. And then the same idea is for division. So if you're dividing with the same base, subtract the exponents. If you're dividing the same exponent, you can distribute. And the negative exponent means reciprocal the base. Negative exponent means reciprocal the base. So let's try some examples. 6 to the 1/2 times 6 to the 1/3. Well, I'm multiplying with the same base, so that means I would add my exponents. So 1/2 plus 1/3. Oh, but wait, I need a common denominator, so that would probably be 6. I'll multiply the first one by 3, the second one by 2. So that'll give me 6 to the 5/6. Now, since they gave us the problem as exponents, we're going to leave it as exponents. You usually wouldn't write that as 6th root of 6 to the 5th. Let's try another one. Well, I see we're multiplying, and we have an exponent on the outside, so we can distribute that to the two parts. And when you have exponent parenthesis exponent, multiply the exponents. So that would be 27 to the 2/3 and 6 to the 2/4. Alright, now here's where it starts getting tricky, because that's like the cube root of 27. But I know the cube root of 27. So this is like cube root of 27 squared. Now I'm not doing the square root of 6 because that's not anything, that's not exact. But the cube root of 27 is 3. And 3 squared is 9. So this would be 9 times 6 to the 1/2. So if you can simplify, do so. All right, let's throw in some letters to make it interesting. All right, again, I see we're multiplying. So we can distribute this exponent. So we have 4 cubed. So you'll end up multiplying the exponents. So that'd be 4 to the -1, w to the -1. That means we're going to reciprocal. It'll be 1 over 4 and 1 over w. Well, we'd usually write that as 1 over 4w. All right, on this one we're dividing. The exponent on top is a 1. So when you divide with the same base, you subtract the exponents. It'll be 1 minus 3/4. 1 minus 3/4 is 1/4. So it's t to the 1/4. So that was properties of exponents. What about properties of radicals? We have the product property, which is the same as the product property for the exponents. So if you have the same exponent. So you have two things multiplied together with an exponent. You can distribute it to the two parts. Same ideas. Remember, radicals are exponents. And the same thing with the quotient property. If you're dividing with the radical, you can distribute that to the two parts, just like if they were exponents. So let's do some more examples. The cube root of 25 times the cube root of 5. The 25 is just 5 times 5, so I can't even get a group of 3. But maybe I could, since they're the same index, we could just multiply it together. 5 times 25 is 125. And then maybe we could simplify that. It's 5 times 25, and 25 is 5 times 5. So this would be the cube root of 5 times 5 times 5. The index is 3, so I have a group of 3 5s. The group comes out once. There's nothing left. How about this one? We're dividing. It's the same index. That means we could actually divide inside the radical. 32 divided by 4 is 8, and x divided by x is 1. They cancel out. And the cube root of 8 is 2. All right, so but what if those radicals don't come out perfectly? So to write them in simplest form, you have to remove any perfect roots and rationalize the denominators. So the fourth root is 64. Well, 64 is 2 times 32. 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4, and 4 is 2 times 2. So that's the fourth root of 1, 2, 3, 4, 5, 6 2's. Now I want groups of 4. So I have one group of 4 2's. So I can bring that 2 out. And then I have the fourth root of 2 times 2. Usually that's it. Usually you'd say, oh, it's 2 fourth root of 4. But we're not saying that for this one. Why? If the index and exponent are reducible, then reduce. Because that's the same thing as 2 to the 2 fourths. So remember, the index is the denominator of the exponent. And the 2 over the 4 reduces, so it could be 2 to the 1/2, which is the square root of 2. And I moved it back to a square root because the original problem was in radical form. The fourth root of 7 over 8. Okay, that means pretty straightforward. It'd be fourth root of 7 over the fourth root of 8. 8 is 2 times 4. Hey, that's only 3 2's. I can't get a group of 4 2's. But I can't have a radical in the denominator. So what I have to do is I need to fill up the group. So I have 3 2's. I need a fourth 2 in the denominator. So I'm going to multiply the top and bottom by the fourth root of 2. And I'm picking that, so now I have 4 2's in the denominator. I can't reduce the index with anything because there's no exponent. 14 is just 2 times 7, so I can't simplify that any, so we're done. But wait, there's more. All right. So this would be like the 5th root of x to the 5th over the 5th root of y to the 8th. All right, I believe on the top, can I say that you see that there are 5 x's? So one group of 5 x's. On the bottom, we have one group of 5 y's and then 3 more y's left over. Right, because to the 8th is like that. Multiply together. So that means I need 2 more y's in the bottom. So I'm going to multiply by the 5th root of y squared. And I'm doing that so I end up with that will make a group of 5 y's. So on top of x, 5th root of y squared. On the bottom, I have one group of y's and another group of y's. So it'll be the 5th root of y squared over y squared. The y squareds do not cancel because one is inside of the 5th root, the other is not. So that there is the answer. Let's try another one. Well, this one's different. For these kind, worry about each individual variable individually. So 18 divided by 6 is 3. This is r to the 1st divided by r to the 1/4. Since I'm dividing, I would subtract the exponents. Then I have the s on top. And on the bottom, I have this t to the -3. So the negative exponent means I'm going to reciprocal it, and it'll actually end up being on top. All right, let's simplify the r. 1 minus 1/4 is 3/4. So I have 3r to the 3/4, s to the 2/3, t cubed. But wait, there's still more. Last concept, adding and subtracting. Simplify your radicals and combine like terms. For example, on this first one, notice this 4 to the 3/4 is the same in both. So we have 5 of them, and we're subtracting 3 of them, which would leave 2 of them. All right, let's make it a little bit more interesting. All right, we need to simplify each radical. So 81 is 9 times 9, and 9 is 3 times 3. So I have a group of 3 3's, so that can come out. And I have 1 3 left over, so it stays there. And the cube root of 3, it can't be simplified. So I have 3 of these cube roots minus 1 of the cube roots. 3 minus 1 would be 2 cube roots of 3. Last example. All right, 6 is just 2 times 3, so that's not getting me any groups. But x to the 5th, there is one group of x's there. So for the first one, I can bring out a group of x's. And on the second one, I can't simplify that any because 6 is just 2 times 3, and at x, there's no groups of 4. But hey, look at this. If I take all of that, it's like terms. I have 2 of them plus 1 of them makes 3 of them. All right, that's it. That's all for today. Have a good day.